Right, DC circuits. You do this reasonably thoroughly in level 1, if you did level 1. So, I don't know how much I'll dwell on this, but I just want to talk a little bit about, just make sure you've got the whole parallel circuit thing sorted out. So we'll just draw a quick parallel circuit with two lamps. And you all knew that when you had lamps in series, total resistance was just equal to R1 plus R2. Now in a circuit like this, if both these lamps are 20 ohms, and say this voltage is 12 volts, then if I want to work out how much current's going to flow, I can do it the sort of level 1 way, which would just be go 12 divided by 20, right? That's voltage divided by resistance. I know that I'd get 0.6 amps here and 0.6 amps here, so they'd both add up to 1.2 amps, right? And I would know that if I wanted to work out the total resistance of the circuit, I'd just go voltage supply divided by current equals total resistance or effective resistance, and I'd go, well, 12 divided by 1.2, let's do it, 12 divided by 1.2, and you all know, is 10 ohms. You go, oh, that's interesting. I had a 20 ohm and a 20 ohm together, and now I've got 10 ohms. So the parallel circuit rule is one where you go 1 over total resistance equals 1 over R1 plus 1 over R2. Don't have to be the same. We could have made it much more complicated. Which in this circuit is 1 over 20 plus 1 over 20 equals 1 over RT. 1/20th and 1/20th is 2/20ths equals 1 over RT. Alright, 2/20ths is 1/10. So when we've got 1/10, this is a good place to look at the inverse key on your calculator, right? When you've got 1 over RT equals 1/10, well, 1/10 is 1. So on your calculator, just go, well, you've ended up with 0.1. And the reason I'm doing this is because it's often a lot more complicated. Just go x to the minus 1, and it gives you 10. So x to the minus 1 on your calculator sort of flicks these guys. It takes the inverse. So when you need to divide into 1 to get an answer, you just use x to the minus 1 and it will do it. It's just very convenient. And that obviously equals 10. So this formula that we had was able to work out the effective resistance in the circuit. We didn't have to work them out individually. So it was very nice for that. Some of the kids in level 1 knew how to do this and some don't, which is why I'm just making the video. When you move up to doing slightly more complicated circuits, you might have one that sort of goes like this. You've got a resistor, then you've got a couple of resistors here, and maybe you've got one here, right? And maybe one like that, doesn't matter. One like that, and one like that. So it all gets a bit tricky, right? So we've got 1, 2, 3, 4, 5, 6, 7, 8 resistors in there. Now, what you can do, whenever you've got series, you can add these guys up as one resistor. You just add them. So if I put numbers on these, if I call this one, if these are all, I don't know, 4 ohm resistors, these are all 4 ohms. So what I can do is I can go, okay, if they're all 4 ohms, that means these two are in series, therefore the 8. Alright? Okay, that's good. Alright, now I need to work out what this one's just 4. That one's obviously 4 and 4, so these two, as they go around the corner here, are 8. But these are in parallel. So I need to do my little formula so I can make those guys into one resistor, right? And once I make those guys into one resistor, I go 1 over 4 plus 1 over 4 is 2 over 4, right? 1/4 and 1/4 is 2/4, and then we inverse it. And so this ends up being 2. All right, we know this one's 4. So I can now redraw that circuit. It's still reasonably complicated, but I think we're making progress. If I redraw that circuit, it's sort of like I've still got my 4 here. Now I've got 8. I combined my 2 resistors there. I've still got my resistor 4 here. So I've got 8, 4. I've still got my 4 there. I've got 8 here now. That one. And I've got 2 here now. And these are all connected like this. So I've definitely made some progress. What can I do with these? That one was 2. Now I can go, okay, these 2 are connected together. I can make those 10. Alright. Now, the way I can solve this is I can go, okay, now I've got 3 resistors in parallel. So I can go 1 over 8 plus 1 over 4 plus 1 over 10 is equal to 1 over RT. And that will effectively give me the equivalent of 1 resistor. Alright, so 1/8 is equal to 0.125, 1/4 is equal to 0.25, 1/10 is equal to 0.1, 1 over RT. Alright, so I go, okay, 1 divided by 8, we'll just make sure I was right. Yeah, I was right. Plus 0.25 plus 0.1, all comes out to be 0.475. I want to inverse that, divide it into 1 to get my RT, so I just use my x to the minus 1 key, and I ended up with 2.1. 2.1 ohms. Let's just lift that up so you can see it. So I've got the equivalent resistance through doing my parallel section here of 2.1 ohms. So now I'm left with a circuit where I can go, actually, now I've just got 4 ohms and 2.1. So that's equivalent to 6.1. I can say, that's a series circuit, 6.1, right? And if I want to know the current in it, well, what's the voltage? We go back to the original circuit, and we say, okay, 12 volts divided by 6.1, and I know that my current would be 1.96 amps. So what you end up with is a very simple circuit after we started off with one that had 1, 2, 3, 4, 5, 6, 7, 8 resistors. What did we do? When we saw series, we combined them, boom, boom. When we saw parallel, we did our parallel calculation and made 1 resistor out of it. And then we would continue doing that till we simplified it. That's parallel circuits and complex circuits.